talk at CF Hyderabad chapter. So I am Kedar. I work at TransUnion as Senior DevOps and SRE. So I'll be talking about Cortex and Mimir. So hello, you can hear me? Backside? Yeah. Okay. Yeah. So as I said, I'll be talking about Cortex and Mimir. Yeah, today's theme is observability. So how many of you know exactly what observability is? Raise your hands if you know. There is no one correct answer, obviously. So can anyone tell me what observability is? Mic is there.
Simple question. I think someone should be able to answer what observability is.
I'll just use
yeah,
that.
Shout.
Observe the performance. Okay, this one.
Okay, Kedar, we have an answer. Collecting data to
Observe the application or infrastructure.
Yeah, right. So it's a way to see or monitor the state of an target application resource or service over time. So observability is basically built on three main pillars. Okay. Excuse me.
Sorry, that's not
So observability is mainly built on three pillars. One is logging, monitoring, and tracing. So this metrics, where does it come? So it comes into the monitoring section of that things. So let's move. Yeah. Now, what are metrics? Metrics are basically a form of they basically are used to monitor few things like availability, like uptime, downtime, throughput, number of requests processed per second, error rate, like how many requests are failed in that period of time, certain period of time, and they mainly deal with CPU metrics, memory, disk usage, network throughput, all these things. So how do you collect all these metrics? You are running your application in a GKE cluster, let's say, or EKS, whatever, Kubernetes cluster. So how do you collect all these metrics? So one popular way to do that is using Prometheus. You install a Prometheus agent inside that cluster, which collects all that metrics, and it will send it to it will store in a time series database, and Grafana is used to weave that in all these metrics in the UI, and you can configure alerting rules in Prometheus or in Grafana. It's your choice. So it's fine. It's all well and good if there is only one Kubernetes cluster. Now, modern infra in a mid-sized company, let's say there are like 50, 60 clusters running, Kubernetes clusters running. So there are so many services, and you can't deploy multiple Grafana instances. There will be different, like 50, 60 Grafana URLs. You can't keep track of that, right? You want everything centralized and only one Grafana to see all the metrics from all those 50, 60 clusters. So what is the solution for that? There is this product called Cortex. It was first developed in 2016 by Tom and Julius. So they were main authors of this, and then Tom moved in to Grafana Labs, and from then Grafana Labs became major contributor to Cortex. And Cortex was incubated, it was a sandbox project in CNCF in 2018, and then now, presently, as of now, it's an incubating project. So why is Cortex a solution to the problem which we discussed before, right? There are multiple Prometheus instances, possibly in different clusters. They'll all send these metrics which they collected from their own clusters into Cortex. So Cortex stores all these clusters into a database. That database is basically an object storage. It can be an Amazon S3 or GCS, anything like that. So, and there is one Grafana instance running, and Cortex, what it does is it basically divides every cluster metrics as tenants. So you can just switch tenants and you can see the metrics of your desired cluster. So this is the solution. Now, this is the Cortex architecture. There is a lot going on here. There are so many components like distributor, ingester, which we'll see going forward. This, as I said before, it uses object storage for long-term metric storage. And Prometheus, it will just push all these metrics to Cortex agent, and it's stored in S3 or GCS. And the multi-tenancy is the one where you can divide metrics of different clusters, and you can switch the tenants and then see the metrics of your cluster. Yeah, but Cortex at that point of time, when it was started, it was having this operational complexity, and it was difficult to scale. There were a lot of pains with that. So that's why this person, Tom, he just went to Grafana, and they have created a product called Mimir. So Mimir is basically, it's forked from Cortex repo only. So you will find a lot of similarities there. And they try to address a lot of limitations that Cortex had back then. Okay. And another thing that's changed between Cortex and Mimir is the license. It's important to understand what these licenses are. Apache license is a more open license, and it allows people to fork or copy the code, make changes and make it their own business solution. Like it's fine if they don't make it open source. But AGPL license, it doesn't allow you to do that. If you fork a repo from a AGPL product, you have to make those changes publicly available, and it should be open source. So they have changed from Apache to AGPL so that Mimir has its own ownership on that. Yeah. So what limitations does Mimir address is these things. So it's performance and scalability. You have more, you can store billions of metrics in that, and you can query all these metrics 40 times faster than Cortex. So it's very simplified. The documentation is very neat, and you can easily get started with that. So yeah, and reduce complexity. And since it's a Grafana's product, there are already predefined dashboards, rules, and playbooks. Yeah, as shown here, there are a lot of components, right? It's hard to remember how many components are there and what each does. So they have simplified it and divided it into two paths, read path and write path. So has anybody installed Prometheus before in a Kubernetes cluster? Okay, so for those who don't know, it's basically installed using a Helm chart, and there are a few components that are installed in the cluster. One is node exporter, Prometheus server, and optionally kubestate metrics. What node exporter does is, it is installed in the cluster in every node as a daemon set. In the daemon set, one node exporter per node in a cluster. So what it does is, it will scrape all the metrics and it will make it available at some endpoint, basically /metrics or something if you configure it, if you customize it. And Prometheus server, what it does is, it will take all the metrics from all these node exporters. It will filter those metrics, drop the unnecessary metrics based on your configuration, and it will send all those metrics to distributor using something called remote write functionality, right? So what distributor does is, it will accept all these Prometheus metrics, it will do the authorization and tenant-based authorization, all that stuff, and it will send all the samples, like metric samples, into the ingester. You can run one or more replicas of ingester, so it will do replication or sharding. Distributor does that, replication or sharding. And ingester, it will store all these metrics in memory based on the tenant. For every 2 hours, it will push all those metrics to object storage. That retention period, 2 hours, you can customize it as well. So ingester has something called val. It's a write-ahead log. It's like an index. If suppose an ingester pod goes down or it crashes, a new ingester pod comes up, it looks at that val and it will continue the process from there. So once the metrics are stored in object storage, there is a component called compactor. What it does is, it will help you save your valets. It will reduce the object storage cost by removing duplicates from multiple replicas of ingester, and it will make it easy for us to store all the metrics in the object storage. Now coming to the right path, once these metrics are stored, you have to query it, you have to see the dashboard, graphs and all that stuff, right? So when you write a query, it will come to the query front end, and depending on the range, let's say you have written a query for 2 years, 1 year, it's a large time range, right? So query front end, it splits that query into multiple smaller pieces and it will put that in a queue. This query scheduler is optional as indicated there. If query scheduler is running, then the queue is maintained by it. If query scheduler is not running, the queue is maintained in query front end. So querier, what it does, it's like a worker. It will pull all the requests present in that queue of query front end, and it will look at ingester. I mean, it will talk with ingester and cache. All these components optionally maintain a cache. So if you repeatedly execute the same query, it doesn't hit the object storage, it will just look at the cache and give you the results. So querier hits the ingester pods because ingester has its own memory for 2 hours, right? So within 2 hours, if you are querying something, it will look at ingester's memory and give you the result. So that way, the number of hits that you make to the S3 or GCS is reduced, thereby saving more cost. And if you are looking at an older data like 1 year, 2 years, then it will send that request to store gateway, and store gateway executes the query for you. These are basically the same things highlighted, what each component does: distributor, ingester, store gateway, and there is a query scheduler that is optional, which maintains the memory queue. Compactor, as I said, reduces the storage cost by removing the duplicates and all that stuff. So ruler, it's what it does, it will basically have all the rules. Whenever something goes wrong, you get an alert because ruler sends that trigger an alert to the alert manager, and based on what you configured like Slack or email, alert manager sends you an alert. But these are optional because Grafana already comes with all these features. Yeah, and there is another optional component called override exporters, where you have pertinent limits. If some cluster is sending all the metrics continuously non-stop, and you want to put some limit on that, this will be helpful. Okay, now you like Mimir and you want to deploy that in your cluster. There are 2 ways to do that. One is monolithic and one is microservices mode. And you are still confused with all the components, you don't want to deal with that stuff. So then Mimir is deployed as a single pod, and in that single pod, all the components which we discussed before are running as processes instead of separate pods or something, right? So this is really helpful when you want to run Mimir in your local system or local Kubernetes cluster and you want to get used to it first. But microservices is more like production ready stuff. So you can run multiple replicas of each component. If your team is like having lot of Grafana users, then query frontend can be there can be more replicas of query frontend to process all that queries and all. Yeah. So one thing is okay, the QR code is missing. Fine. Monolithic mode, Grafana by default provides only a Docker Compose file, right? So if you have a local Kubernetes cluster and you want to use a Helm chart, I have created one Helm chart and made it publicly available in a repo. I added a QR here, but it's missing. I'll get that. Oh, okay, now it's there. Yeah, right. So you can just scan this repo and get your Helm chart. Does anyone know about hash strings?
Give some time for QR.
Okay, if anybody wants to scan, sorry. So you can just basically pull this Helm chart and do a Helm install, and it will have all the Grafana, Mimir, Mini.io, like the backend, all the things required to just run the application. Done? Yeah, so I wanted to talk about this topic because it's not only specific to Mimir, it's used in a lot of other technologies as well, popular technologies. So does anyone has idea about this hash strings? Anyone knows consistent hashing? Okay. So let us first see the features that are built using hashing. So hash rings are used in service discovery and heartbeats. So heartbeats, okay, let's say there are multiple ingester replicas or replicas of any pod or application. How will one replica know if other replica is alive or not? It's using heartbeats. Each replica will send a heartbeat like I'm alive, saying something like that, and other replicas receive it, and they know that this particular replica is alive and running well. So there is zone-aware replication. This is similar to the thing you see in AWS. You can replicate your metrics in different zones. That's something that is possible using hash rings. And there is something called shuffle sharding, which we'll see in next slide. Okay, so what is this? What is hashing? So let's take an example first. There is a restaurant and there are several orders coming in. The restaurant has 3 drivers, Alice, Bob and Charlie, let's say. They have a simple hashing algorithm, like divide the order ID with the number of drivers, and then that will, based on the reminder, it will be decided which order has to go to which driver. Okay, this is nice and well. I mean, it works well until one of the drivers says, okay, I quit. Okay, now there are only 2 drivers. Now the hash algorithm changes by 2. So the value changes. So the orders need to be reassigned again. In software terminology, these drivers are basically servers, and whenever a request comes in, it goes through a hash algorithm, and that output decides which request needs to go to which server. But if a server crashes suddenly, all the requests need to be reassigned, which is quite expensive actually. Okay, so in order to solve that, they have come up with something called this hash ring. Okay, whenever a request comes in, it goes through that hash function, and see that order 25 is coming, it will go clockwise and see what server is located there. It will be assigned to that particular server. Let's say if Bob says I quit, the order 25 goes clockwise, it will be assigned to Charlie. Now, when someone is quitting or a server is crashing, you are not assigning all the requests. You are just making that request go to another server. So that way you can save all the expensive stuff, right? It's quite similar to the game Truth and Dare, where you put a bottle, you rotate it, and wherever it stops, if the person is not there, it will just go to the next person, right? So we'll come to shuffle sharding next. So before that, Mimir uses these hash rings for sharding and replication. We saw that sharding and replication, it is used in distributors, mainly when it's passing on the metrics it received from Prometheus to ingester replicas. So anyone knows what is sharding? Okay, so with a simple example, I can explain what is sharding. Let's say there are a pile of Legos and you want to sort them based on color. Okay, when you are the only person doing it, it will take a lot of time, right? But if you have so many people, you can just give small piles to each one of them, and once it's sorted, you can just aggregate them properly, right? So this is basically sharding. You are sharding your big pile of Legos and you are distributing it to different people, right? It's a fancy way of saying distributing your work, right? So this is without sharding. Every server is sending all the requests to a single server. Every client is sending requests to a single server. But with sharding, you are distributing work between different servers. But sharding is fine until there is some problem, right? So there is let's say a client is compromised and there is denial of service attack, where you send lot of requests and the shard or server which is processing those requests is quite overwhelmed, and it basically crashes. When it crashes, the B data is also lost. Okay, yeah, when that server crashes, the B data is also lost. But with shuffle sharding, you are, let's take the same example only. When A is compromised and there is a denial of service attack from A, even though B and C is lost here, it's replicated in some other server. So you are saving that data, and there is no loss of data basically. There is no single point of failure. So Mimir uses shuffle sharding in front load balancing, data retrieval, all this stuff which is mentioned there. And shuffle sharding is not only used in Mimir, it's used in many things like Route 53, Pyroscope, MongoDB, Elasticsearch and more. Hash rings are used in Cassandra, DynamoDB, CDNs. CDNs are content delivery networks. GitLab uses hash rings, yeah. So there are many other features that come with Mimir. The ones marked with M are exclusive to Mimir, and the ones which are not marked, they are both available in Cortex and Mimir. So you can ingest a circuit breakers. You can, if let's say there is an operation that will fail, you can block it using blocking queries. You can have circuit breakers, and there are limiters that you can have in Mimir. Yeah, so that's all for this presentation. All these examples, all the content which I explained right now, if you are interested in learning more about them and you want hands-on demo examples, there is step-by-step explanation in my blog. And if you want to connect with me, that's the LinkedIn QR.